Okay, so hello everybody. I'm glad you are here, and I hope you can hear me. Or is it okay even here in back? Okay. So my name is Adéla Haníková, and I prepared a presentation for you named "To Use or Not to Use JWT," which is inspired by several assessments I have during the last year work. So at first, a little bit about myself. I'm technically studied like cryptographer, although the official name of the studying program was like mathematical methods of information security. So there was a lot of math and some information security. And this is like the book that started all, like, which I read during my studies when I was in the secondary grammar school, and why I became interested in ciphers. During studies, we started solving CTFs competitions, which bring me more to the information security. Right after that, I became a pen tester in a Czech company named AEC, which is now ARICOMA. Now I focus mainly on web application testing and infrastructure testing. And a few years ago, I gained the OSCP certification, probably the only one I'm at least a bit proud of, and the only one which is still valid, because it doesn't expire. So now a little bit about JWT. What is it? Not sure if everyone knows it, so we will do some brief introduction. First, the acronym is for JSON Web Token, from which you can deduce that it's some token and the information in it is stored in a JSON format. It is divided into three main parts: the header, the body, and the signature of the token. In the header, you have some information like about the token itself, what algorithms are used, and things like that. In the body, you have the information you want to carry in the token, and there can be, I think I can say, like literally anything. And then there is a signature that assures that the token is valid and it was not modified when you are communicating with the server. If you spot it in the wild, it looks like that. These three parts are divided by a dot, and all the three parts are base 64 encoded without the trailing equal signs, which are omitted. Every time it begins with the E, Y, J, because it's the base 64 encoding of the, yes, I will show, of the curly brackets and the quotes. So here is like some really simple example of the JWT token which I made, and some maybe important informations are in the header. You have already every time the algorithm specified, which is used for the signature, and here is the symmetric algorithm HS256. Which is one of the most common algorithm used. Also not the only one, but to be honest, I didn't see the other ones anytime. And then there is the body. Although almost anything can be in the information, the really typical ones are expiration, whereas like the expiration of the token until the time until the token is valid, which is quite important. Then typical some username or name of the user or any identification. It can be also an email, and then there can be stored, or quite often stored, some user role or just simple claim if the admin role is true or false or something like that. So now what's like good about the tokens, or why anybody would like to use it, is that everything is like carried in the token. and you then have to store the information on the server. If you know like what typical session handling is, then you have some random string, and you store the information about things like that, the expression or what username it is, what role it has on the server in some kind of database. And every time you get a request, you see there is some random identifier, and I have to look like what the user is talking to me. When you use JWT tokens, this information don't have to be looked up in the database. You just have to decode the token and verify it, which is well good, for example, for stateless applications. But so, what can be the issues with JWT tokens? There are, let's say, two types of issue which can arise. The first are the let's say typical vulnerabilities which can be with JWT tokens and which can be, I would say, I guess, easily handled. I will just mention them here. The first one are the most known. It's not checking the signature of the token at all when you just decode the token and take the data as valid. Even if you do not check the signature, it's because some programming languages have different functions for decoding and verifying, and the developers might not be aware of that. Then there is the non-algorithm, which is valid, according to specification, it's a valid algorithm which can be used in JWT tokens. This means that there is no signature at all. So you have to be aware of that. You should not accept the token without the signature, obviously, because then the information in the body can be modified by the attacker. Then also, when you use the symmetric algorithm, you use some secret key for the signature, and well, it's a secret key. It's something like password. It can be brute forced. So if you choose a weak password or weak secret, the attacker can brute force this and then create their own tokens with their own information. These are the main, most known. Then there is also vulnerabilities which are of JWT or JKU or key ID injections. These are parameters which are used in the header part if you don't use the HMAC, the symmetric encryption, but asymmetric algorithms. But that's not what I will talk about here. I just wanted to mention it to be complete. The more, let's say, complex, although with not such big impact, is how to handle the tokens when you use them in typical web application. Really, you can imagine any web application you use where you have some login, then you log into the application, you can see some data here or something like that, and then you can log out. I had several penetration tests of such applications, and they use JWT tokens. Mainly it was because they called API services in the background, and these API services accepted JWT tokens, which is quite, don't want to say normal, but typical architecture. So what can be issues, or what I was struggling with? The first thing is how to log out from the application, how to end the session, because as I mentioned a little bit, and we will get to it, you have nothing on the server, and there's an expiration date in the token itself. And the second thing is how to store the token. Yes, and we will look at these 2 points a little bit more in detail in this slide. First thing is the invalidation of the token, or just logging out. When we are testing web applications, our main methodology is the OWASP testing guide. And then some, like what you think about, your own thoughts, you can say. And the first thing which is, at least for me, like quite essential, is that when you log out, the session identifier should be invalid. But that's not true with JWT tokens, because usually, or in most applications I tested, I think the logout was performed by deleting the JWT token, but the token was still valid until it expired. So if the attacker can steal the token, like the logging out would not stop the attacker from performing any actions on the website. And there's also one thing which is not implemented in all applications, but sometimes you also want to end any parallel sessions you have. And again, there is like if you just use the JWT tokens, there is no way how to end any parallel sessions, because there's no evidence of any sessions on the server itself. Like these 2 points are from, I will just mention the resources, from the part 6 of session testing of OWASP guide. And here you can see like really screenshot from the OWASP testing guide. And like the problematic part, I would say, is mainly the last point, which says that the sessions should be proper invalidated server-side. This is a little bit, like at least for me, it was a little bit tricky during testing, because like you don't have any server-side session state. So was it invalidated or not? Should we report it or not? Then the second part is storage of the token. It is possible to like have the token in the cookie and send it in the cookie, and then there is no issue if the cookie is properly secured, and you can work as a typically session cookie. But it's not usually the case, because JWT tokens are usually sent in the authorization headers. And if you have a website and want to send the token in the authorization header, then the token has to be somehow accessible to JavaScript to edit manually. But this means, I think, I'm not a developer, so maybe I'm not completely correct, but it means that if you had an XSS issue on the website, then the token can be still using the XSS vulnerability, and again, used somewhere else. This part is in the session 1 part of the OWASP testing guide, and there is like this one, I would say the main point is when you have a cookie where session information or session identifier is stored, the cookie should be HTTP only. So it cannot be readable by a script. Well, and there were some assessment where this was definitely not fulfilled, because the flow of the application or the architecture was that the token was from the server was sent in the cookie, but then processed by the JavaScript and sent in the authorization header in other requests. So obviously, the cookie did not have the HTTP only parameter, because the developer wants to access the information in the cookie. So here's like, well, this is clear. This is a finding, because the cookie has a session information in it, and it does not have the HTTP only parameter. The only problem, or maybe only my problem, was what to recommend to the customer, because the typical recommendation is to add the HTTP only flag, and the problem is solved. But if they would do this, the whole application would stop working, because they really needed to access the cookie. Another option is to say, so do not set the token in the cookie, but send it in the response in some JSON, for example. This would solve like this one point. There would be no cookie without HTTP only parameter, but still the token would be readable by a script, which is, at least for me, the main problem. So I was like thinking about it, wondering if I'm just overthinking it and should let it be, or if it's really an issue. So then I decided to look at ASVS, which is like more, let's say, more detailed list or checklist for application testing, which we do not use typically for our assessments, but definitely we can. And I will just briefly say what it is, because I did not remember even myself. It's borrowed picture. And the OWASP application security verification standard is like a list of more than 200 or almost 300 controls divided into 14 topics, where you have really one or two sentences, what concrete thing you should check. And every check, or the checks are not checks. The standard is divided into like 3 levels. If you want to pass level 1, which is really like, you can see low assurance level, and it's like basically every application should pass the level 1, then you have to pass just some 130 controls. And then if you have something like a typical web application handling some sensitive data, logging user in and out, then you should pass the level 2, or at least it's mentioned like that. And then there is level 3, which is really for the most critical applications. In this like checklist, there are 2 parts which are interesting, or which are related to this topic. The first part is about some session binding, where the important point is the third one, where you should verify that the application stores tokens in the browser using secure methods. Well, these can be secured cookies or HTML5 session storage, which is accepted there. So there is probably a way how to store the token. And then there is part about session termination. And here we have more interesting points. The first one is to verify that the logout invalidates the session token, even for relying parties. And as we can see, this should be like even layer 1 application should pass this check, which is, I think, the key one for this. And then there is the third point, where you should verify that the application gives the option to terminate all other active sessions after a successful password change, for example. And the fourth point, where you should verify the users can view the other active sessions and end the active sessions they want. These are not for layer 1, these are just layer 2 applications, and I would say maybe even just for some of them, or it's not really common in all applications that you can see your other sessions. So this was like, okay, I think these are issues, but what can be done with this? Like, is there a possibility how to properly implement some session handling using JWT tokens, or is it like just they should not be used at all? So I, again, was looking on the internet to find some how to do it, and I found again a OWASP guide, which is Java JWT Java implementation cheat sheet. It is called Java implementation cheat sheet, but like the description of everything is, I would say, like for every programming language, the only thing is that for Java they are code snippets that you can maybe even copy and paste and use. And maybe there are some small issues which are typical for Java mentioned there, but you can use like the whole thing or message of this cheat sheet and implement it everywhere, anywhere. They are talking about a lot of issues which are connected with JWT tokens, even for example with the NaN algorithm. And I choose 3 of the topics that I mentioned, which are connected with these issues I already talked about. And in these 3 slides, I will talk about these 3 issues they have, and all the text is just really copied and pasted from the website. It is somehow sometimes a little bit, what I would say, strange, but I left it as it is, and I will just comment it. So the first thing they are talking about, which should be addressed, is token side checking, which happens when the token has been intercepted or stolen somehow by an attacker. Yeah. Like from the solution description, I guess they mainly mean if it's stolen using some XSS attack, or maybe read from the browser memory. So what is their solution to this is to add something they call user context in the token. And technically this means that you will not generate and send with the request just a token, but also a random string which will be stored in a properly hardened cookie. This is technically like a session cookie, or it will look like a session cookie from the user perspective, as if I understood it correctly. And you will send this random string in the cookie, and then you will have a hash of this random string in the body of the token. And you have to send them both, of course. And then when you receive a request from the server and you do the token validation, then you have to like take the hash and compare it to the hash of the cookie you received with the token. If they match together, then everything is okay. If they do not match, or if there is no cookie at all, you should reject the request. From their point of view, this is a solution to the problem, and I guess it's because they think, or that the properly secured cookie will not be intercepted anyhow, because there's the HTTP only secure parameters, so it will be not sent over HTTP. It cannot be accessed by the JavaScript. It is stored securely in the browser. So this is like their solution to token side checking, but you will see it's technically a solution to everything. The second thing they mention is the no built-in token revocation. So the fact that you cannot log out the user, or you cannot say the token is invalid. It's like inherent to JWT, because like in the JWT itself, the only thing or the only way how it becomes invalid is when it expires. But, well, one thing is, what they say, that the well-implemented token sidechain solution should solve even this issue. And again, they say this is because the cookie can be considered as secure as the session ID when you use traditional session system, and that's like the reason why they believe it. Maybe I do not understand everything completely, but I think it's not completely like foolproof. But definitely it makes the exploitation harder, I think. The other way how to solve this problem and what was like our solution when we are discussing it in the office is to have some denial list of the tokens on the server side that will like mimic the logout feature. In this denial list, you should keep, or it's enough to keep just a hash of the token, which should be invalidated, and then some revocation date or the time until when it should stay in the list. When you have database like this, you do not solve, or you still have to the database. Also, probably maybe the reason why you chose JWT tokens was that you didn't want to have anything like this. But this one at least would be much smaller, as you will keep just the tokens that should not be valid, and you keep just like the hash of the token and some time expiration, not any information about the user or rows or anything. Here maybe another option, which I do not have written here, is that you can use someone else's solution who already solved it, as one assessment where during which I met also JWT tokens, and there was also the logout feature in the web application. They used AWS Cognito pool for managing users and even for like creating the tokens. And in AWS, this some kind of deny list or blacklist is implemented. So if you like log out in the Cognito pool, the token is invalidated. The only problem during this assessment was that they did not check this. So when the user logged out, the token was invalid when you asked the Cognito pool, but was still valid if you asked the application. So you have to check it. And the third thing is how to store the token on the client side if you want to send it during in the header. Then there are like three main issues they are talking about. And the first one they mention is even if the token gets automatically sent by the browser, so if it's in the cookie and somehow in the cookie storage. And the reason why they mention it, I hope, is just that if you use this solution, if you have the token in the cookie, it's like safe against, if the cookie is properly secured, it's safe against XSS, but you have to deal with the cross-site request forgery, which is, but this is something well known. There are ways how to handle them. So I wouldn't see this really as an issue, just that you have to think about it and not not forget that even you don't use like typical session cookies, but the JWT token, it is still vulnerable to cross-site request forgery if you use cookies. Then issue is if the token stays in the browser even after restart, which is if it's stored in the local storage container. And of course, the problem is if it can be stolen when there is XSS issue. And how to deal with this? Well, again, well, there are 3 points, and if you want to implement it properly, you should do all 3 points. The first thing, which is not, I think it's not complete solution, but it's like mitigating at least a little bit, that you shouldn't use the local storage container, which is persistent at least a little bit, but the session storage container or some JavaScript closures with private variables, which if there is some developer, front-end developer will know better than me what it is concretely. Then you should add it as in the well, authentication header when you are calling the service. And this point is like mitigating the cross-site request forgery issues, because the authentication headers are not automatically sent by the browser. And then again, add the fingerprint information to the token, which is this user context, which we were talking before, which is like a solution to everything, and which helps, like in this case, if you meet the first 2 points, there is still the possibility for the token to be stolen using XSS. So you add the cookie, which cannot be stolen, and then the attacker would have to gain the cookie another way. So these are like official or OWASP recommendation how the token should be implemented properly. So, like, to use or not to use, what is the answer? At first, it's very specific for each case, and definitely there are some use cases where it's good to use JWTs. But it's quite tricky when you are programming, like when you have a typical web application. I would say use it if you want. Just be aware of the problems and that they are there. And like try to mitigate them in this way if you want to, or be prepared that if you will do an assessment, if a penetration test will be performed on the website, that this will be reported. And there is again screenshot from this is from the Java cheat sheet, which I like which says that if your application does not need to be full stateless, you can consider using traditional session system. And it seems to me a little bit like they wanted to say you should consider, but they just think it would be too much. So that's all. Thank you for your attention. And I have this last slide here with the main resources that were used during this presentation. So yeah, if you have any questions.
Okay, are there any questions for Adéla? I didn't get the part about preventing stealing of the session token. No, JWT token. The slide which was 2 slides.
Which one? Like the first one?
No. Go forward.
The last.
It was
the last one.
But one or first but one slide, I think.
This one.
This one. I'm not aware of what does it mean to store this token in the session storage container. Maybe because I didn't write the application.
Well, I don't know how if I can really correctly explain it, as I'm also not a developer. But when you are writing a JavaScript code, there are different, like storages in the browser where you can save some the information you need.
I know that there are session storage and there is local storage, but I'm not aware of
like how they
Is
differ.
Is the session storage container the same as a session storage?
Yes, yes,
Okay.
it should be. Like it should be just the name.
Using JavaScript closures with private variables, I don't know.
Yeah, it's just it's like a feature probably of JavaScript, and how you can like, well, again, I'm not a developer, but the problem that is someone solving JavaScript, that you can have the variable inside the function, which is like private, but when the function like ended, the variable is reset. And then there are global variables which are accessible to everyone, but even to XSS. And these JavaScript closures and private variables are some way how to have private variables accessible only to the function, which will not reset when the function ends.
And regarding the beer HTTP authorization header, I know the request can contain authorization header, and there is colon followed by beer and JWT token string. How it helps preventing stealing the token, or
well,
this slide is about storing the token on the client side. So
yes, it's from the token storage or client side. It's I understand it's not completely clear from this, but this is like even how to like prevent the misuse if the token is stealed, at least for me. And you should like the.
So transferring the token inside the HTTP header or authorization header is better than transferring it in the request body in JSON object.
Well, so this is well, not sure. This is how to handle the or ethics. I thought about it all the time. How to send the token to the server? Then yes, then like sending.
Send the JWT token in the authorization header of the request, then send it in the request body.
Well.
Probably not, but probably I want to say it's better than in the HTTP header as cookie. So I understand it as 1, 2, 3. How to prevent? Do this and do this and then do this.
Yeah, I'm just thinking. Well, I think that they might be similar, but it's not like it's not usual, or how to say it. You know, when you send tokens, you send them in the header or in a cookie, and well, if you will have this such architecture of the application, that the token would be read from the JSON, then maybe, but it's really like strange.
And the colleague in front of me said that I have to perform all the 3 steps.
Yeah.
Steps to prevent stealing of the token or to correctly handle transfer of the JWT token from client to the server. Okay. Thank you.
Okay, once again, thank you for your talk. I believe you can discuss JWT more in the networking part. There are a lot of experts for this. So yeah, we have like 15 minutes break, and then we will continue with the second talk. Thank you.